So what else do we want to do? Don't want to do any reflecting or anything like that?
Sure.
Let's talk about absolute value then. And this is probably not going to show up on your test. It's in your homework, but I just kind of wanted you to think about it. Suppose we want to do the graph of y equals, I don't know, I'm running out of favorite numbers. Does anyone have a favorite number?
5.
We just did 5.
9.
9. Okay, we'll do 9. Okay, what if I wanted to do log base 9 of x? Then that would be an increasing function. Be shaped like this and all that, right? But what if I took the absolute value of that function? What does absolute value do to numbers? It makes them positive. It takes anything that was negative and it makes it positive, and anything that's positive stays positive, right? So normally the log base 9 function would look like, let's see, 1, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 over here, 9 comma 1, and 1 9 comma negative 1 would be right there, ish. And you get that function, okay? But if I'm taking the absolute value of that, then any part of this function that's negative is going to become positive. It's going to take the negative part of this and it's going to reflect it up here. So this part stays like that. But this part down here, you're going to get the reflection over this x-axis. You're going to get like that. And it makes a nice little point here. Isn't that neat? See, you know how to work it. What did I tell you didn't already know? Okay? And then you can translate and all that junk. Alright, last thing from this section before we get to the how do we play with these guys on the calculator. We were defining this log function to be the inverse of the exponential. And we want inverses because these are the functions that undo each other. If I, plug this number into this function, what do I take that out? What do I plug that into to undo everything the other function did and get the same number I started with in the beginning? Right? Well, for the case of exponentials, it's the logs. Alright, so do you agree that if f of x equals, let's say, 3 to the x, is it fair to say that its inverse is the log base 3 of x? That's what we're getting at, right? I need y'all to agree with that before we go on. Okay, so the two of y'all agree with it? Okay, cool. Everyone else does too. So if I plug one guy into the other, they're going to cancel each other out, right? So if I asked you, what is the log base 3 of 3 to the 5th? Then what do you get?
When you expand it?
No, your final answer. It's simple.
Log base 3. Or not.
You get 5. Because the log base 3 composed with the exponential base 3 cancel each other out and you're left with that exponent. What is the log base pi of pi to the 0.5 power? What is, well, let's mix it up. What's 2 to the log base 2 of 11? Are those still a composition of each other? Yeah, this time it's exponential on the outside, log on the inside. Here it was log on the outside, exponential on the inside, but either way they still cancel each other out, and you get 11. Okay, what is
And this is if they're asking you to solve?
Hold that thought.
Okay.
What is 2/3 to the log base 2/3 of your mom?
Your mom.
Yes. As long as your mom's not 0 or negative. Okay? The base and the log, these are designed, these are defined to cancel each other as long as they have the same base. Okay? Like, if I said, what's 4 to the log base 5 of, 4, I don't know. That's much more complicated. When I change the bases up like that, then I gotta do something else. But, guess what, we don't do that. Okay? As long as they have the same base, plug one into the other, they cancel. Alright, here's another way of thinking about it. And you may not remember this because I told you it wasn't a big deal, and it's still not a big deal, but it's a different way of thinking about this. Let's go back to the first one, the log base 3 of 3 to the 5th. That's me taking the log of something with an exponent, right? And one of our properties, in fact, the crown jewel of the properties, the one that I love the most, says I can take that exponent and I can bring it out front as a coefficient, right? So this is 5 times the log base 3 of 3. That was one of the properties. That was a big one. You need to know that. But then we had another minor property that said, what happens if I try to take the log base 3 of 3, the log base b of the same number base? Does anyone remember what that is? It comes out to be 1. This is 1. And what's 5 times 1? 5. And you can think of it like that. Same 5 we got here. Alright, now, Tara brought up solving equations. And that's where we're headed. Oh crap, I hope we don't get there today. Because I have a handout, I don't have it with me. There is a way you can solve equations thinking like this. And this is what your textbook does. And this is what some of the kids in the math lab do, and it's not wrong. And I don't have a problem with it. It's just, it's not going to be the way that I do it. And so that's why I'm just kind of throwing it in here in the end. I think it adds 2 or 3 extra steps to the solving process, which is why I don't usually bother with it. But if after we've talked about solving log equations for a while and you're still not getting it, then chat with me and I'll show you this other way and maybe it'll make more sense. Okay? With that being said, is there anything else from 4 points which you guys wanted to do?